Adding and subtracting algebraic fractions can be a little bit challenging. And it's because as arithmetic goes, people typically struggle with adding and subtracting fractions. Even though add and subtract seems like it should be the easy thing, you know, 2 plus 1 is equal to 3. Shouldn't that be the easy thing? But it's hard because you have to have a common denominator in order to add and subtract fractions. So if you want to add 2/3 and 5/3, you're golden, because they're broken into equal parts, thirds, and you get to just add the numerators and get 7/3 for a solution to this problem. So if I'm adding and subtracting algebraic fractions, if they have the same denominator, then I can go ahead and add their numerators, and if there are like terms, I'll go ahead and put them together over that common denominator. If we're going to be successful adding and subtracting algebraic fractions when we don't have the same denominator, we got to learn how to find a least common denominator. So, you know, there are multiple approaches. You know, one is to take the number 16 and list multiples of it. So if you added 16 to 16, you'd get 32. So that'd be the next multiple. And then if you added 16 to that, you'd get 48. And if you added 16 to that, so these are what I mean by multiples. If you added 16 to that, you'd get 64. The number 24, if you added 24 to itself, you'd get 48. And 24 to that, you'd get 72. But oh, wait. The common denominator is 48 for these two numbers. So, you know, what we end up doing, often I'll say to people, if you've got the 16 and you want to get it up to a 48, you're going to multiply it by 1, 2, 3. In case you struggle with, you know, how many times do I multiply by 16, you can look at the placeholder over here. And this fraction will now be called 3 times 5, which is 15 over 48. The 24, the 48 was the second step in, so if you multiply 24 by 2, you get 48. So right here, you'll have 14 over 48. And you're now allowed to add these, and the numerators add to be 29 over 48, and we're good to go. Well, you know what? This is not going to work for algebraic fractions. So what we have to do is we have to take and factor the denominators. So in this case, the 16 and the 24. So what I do is if a number is even, I say 2 goes into 16 8 times. And if it's still even, I'll say 2 goes into 8 4 times. And the 4 is still even, and I'll say 2 goes into 4 twice. So I'm going to bring all these 2's down. The number 16 is 2 times 2 times 2 times 2. The number 24, I'm sorry, 2 goes into it 12 times. I keep going with 2 if this is even. 2 goes into it 6 times. 2 goes into 6 3 times. And I bring down this 2, and I bring down that 2 and that 2. The least common denominator is found by taking the greatest number of any factors. So you see in the 16, there's 1, 2, 3, 4 2's. See over here, there's 1, 2, 3. So to get the least common denominator, I got to take 4 of those 2's in order to get the least common denominator. And see this 3 right here? That's the greatest number of 3's. 2 times 2 is 4. 2 times 2 is 4. 4 times 4 is 16. 16 times 3 is 48. So I have my least common denominator. If there are no prime factorizations, then your least common denominator is just the 14. Now I'm not going to do this all the time, but it would mean that this fraction would have to be multiplied by 7 over 7 for this to become a 14. And this fraction would be multiplied by 2 over 2 for this to become a 14. So the first one would be a 7x over 14, and the next one would be a 6x over 14. And if I wanted to add those, they'd add to be 13x over 14. Not going to continue that way. So the least common denominator for this one is going to have an x in it, because there's just a single x in each of those. That's the greatest number of times. You can either go 3 times 5 here, and 5 times 5 here. And you can see then that the least common denominator is going to have a 3 in it, and it's going to have 2 5s. So it ends up being 75x is the least common denominator. Again, if there's just numbers, you could list multiples of 15, 30, 45, 60, 75. Then multiples of 25, 50, 75. And that will help you find the common denominator as the numerical values go. So even, this one might be easier to do by multiples. So it might be easier to take your calculator and add 56 to 56, and you'll get, I think, 112. And add 56 to that, and I think you'll get 168. I did not do this way. If I add 56 to that, I'll get 14, carry the 1, 12, 224, I believe. I don't have 196 yet. So if I add 196 to 196, 18, 19, carry the 1, I get 392. I bet that's going to be the common denominator. So I got to keep going out here to get to 392. I'm going to leave it at that. What I want to know from you is, and I better check my notes to see if 392 is, it is, yes, it indeed is the common denominator. You take, for the least common denominator, you take the variables the most number of times they occur in any one denominator. So there's t to the third here, t to the second here. So you're going to have to build up both of these fractions so that they have a t cubed in them so that you could add or subtract those, should that be what you want to do. So let's go to this one next, and then number 5. So as the 8 goes, 8, 16, 24, 32, 40, and as the 20 goes, 20, 40, 60, oh good, I can see that 40 is the least common denominator, but I have to have any of the letters and the greatest number of times they occur in any one denominator. So a R occurs once, a S occurs once in any one denominator, a T occurs once, and ultimately in this problem, I just want you to see this 20ST, I want it to become a 40R ST, so that's going to have to be multiplied by a 2. 20 times 2 will give us the 40, and by an R so that you'll have an RST. So upstairs you'd have to multiply that by a 2R as well. This one would be multiplied by a 5 so that the 5 times 8 becomes a 40. You got the RST. So upstairs would be multiplied by a 5 as well, and that'll become a 25. If the smallest number goes into the biggest number, then the least common denominator is 27, because 27 is a multiple of 3. You only use the letters, you do use the letters the greatest number of times the A's occur. So what is that? A to the second power right here. How about the B's? They equally occur, just B to the first. What's the greatest number of times the C's occur? C to the 4 or C to the 5th? Oh yes, C to the 5th. That's the common denominator. I'm going to have to build these both up to become 27a squared b C to the 5th in order to add or subtract these. So the reason I bothered to show you how to do this with both lists and factors is now we're to that point where we're going to break this denominator into 4 times x minus 1. And this 8x, we're going to break it up into 4 times 2 times x. But remember, the 4 is 2 times 2 times 2 times x. And you see that 4 right there? I'm going to think of that as 2 times 2 times x minus 1. So my LCD has to have the greatest number of 2's. So it looks like it's 3 of them versus 2 of them. And 3 of them make up an 8. It's going to have the greatest number of just a factor of x, and then it's got to have the binomial x minus 1. So when I'm ready, I got to build this fraction up to have all of that as a denominator. So for example, just this second fraction, it's going to need to be multiplied by x minus 1. top and bottom, in order for the denominator to become all of this. I'm not going to finish that right now. I just want to show you how to get the least common denominator. So let's see here. You got to factor the denominators only. So a 3ax is the greatest common factor. So I'm going to pull out a 3ax, and then I'll need an a here, and then I'll need a minus 3 here. The greatest common factor here is a 6a, and then I'm going to need an a minus a 3. So my least common denominator between a 3 and a 6 is a 6. I need a. This is just a factor of a. It's 6 times a times. There's dots between these. There's dots between these. So I need an a. I need this x. And I need the a minus 3 once because it occurs once here and once here. I don't need it more than once because they each already have that a minus 3. Again, you factor the denominators only. So this will factor, oops, I just noticed that there's a 4 that can come out of that. So x squared minus 9. And the 4 will be 2 times 2. And the x squared minus 9 is the difference of squares, x plus 3 times x minus 3. This one has a 3 that can come out of it. So x squared plus 6x plus 9. And then the x squared plus 6x plus 9 can be factored into x plus 3 times x plus 3, because the two numbers whose product is 9 are 3 times 3, and add to be 6 are 3 plus 3. So be careful here. Least common denominator is very large for this one. It's going to include 2 2's, which is going to be a 4. It's going to include a single 3. You see these x plus 3's? They occur twice here and once here. I need to include them twice in my LCD. You see this x minus 3? It is in once in that first denominator. I got to include it. And finally, my LCD will be this 4 times 3, which is 12, times the x plus 3, times the x plus 3, times the x minus 3. And we're going to use this concept in our next segment as we get ready to add and subtract fractions that do not have a common denominator.